Okay, so today's video will be over density again, but we're going to cover a couple different topics about density. So in the last video, you learned that if you need to calculate density, you need the mass and the volume of your object. And we learned how to do the volume of an object by multiplying the length times the width times the height. But what if your object is round, or the length, the width, and height change? Like, what if one side is this thick and on the other side of the object it's this thick? What would you measure for height? Would it be this one or this one? So if your object is irregularly shaped, has an irregular shape, it's not a rectangle or a square shape, you use a graduated cylinder to find its volume. So first, you pour water in your graduated cylinder and you measure the volume. So here I've drawn that. So this is just a graduated cylinder and it has 20 milliliters of water in it. After you measure the volume of your water, you drop your object in the water and you measure the volume again. So here, that's a rock. This is my rock. I dropped it in the water, and now my water measures 40 milliliters. It went up from 20 to 40. So after you drop your object in and you measure the volume, you subtract the first volume from the second volume, here. So let's go ahead and calculate the volume of this rock. If our water was 20 milliliters to begin with, and it went up to 40 milliliters. So you subtract the first volume from the second volume. So 40 minus 20. You're subtracting the first volume from the second volume. So the volume of just the rock is 20. Now, we have to pick a label. But remember that milliliters is the label for liquid density. But a rock is not liquid, it's solid. So whenever you have a solid object, you just change the milliliters into cubic centimeters. They're the same thing. 1 milliliter takes up the same space as 1 cubic centimeter. So our label then is going to be 20 cubic centimeters because it's a solid. So you measure your water, drop it in, measure your water again, subtract, and the difference is your volume. All right, next. What if we want to find the density of a liquid? Finding the volume is not that hard. You just use a graduated cylinder, you measure the number. But what about the mass? You can't pour a liquid on the tray of a triple beam balance because it'll just spill right off. So again, you have to use a graduated cylinder. So all matter has a density, even liquids and gases. But to find the mass of a liquid, you use a graduated cylinder. So first, you find the mass of an empty graduated cylinder. So here's our graduated cylinder. It has nothing in it, and it has a mass of 25 grams. Next, you pour in your liquid, and you find the mass again. So I poured in my liquid. This is green liquid. And I put the graduated cylinder on a triple beam balance, did the scales, the slides, and I found it has a mass of 40 grams now. Then you subtract the first mass from the second mass. So it's very similar to when we found the volume of the rock. It's just now we're finding the mass of our liquid. So you're going to subtract the first mass from the second mass. So our second mass minus our first mass. And make sure you always put your label. So the mass of just the liquid is 15 grams because we subtracted out the mass of the graduated cylinder by itself. So that's how you find the mass of a liquid. From there, you would just look at the lines on the graduated cylinder, find out how many milliliters it is, that would be your volume, and then you would divide this mass by your volume, just like normal. Okay, so we can also tell if something will sink or float based on its density. So we compare its density with the liquid that you're putting it in to see if it'll float or sink. Something will float if its density is lower than the liquid. It will sink if its density is higher. So if the density of your object has a lower number than the liquid, then it will float. And if it has a higher number than the liquid, then it will sink. Liquids will also float or sink with other liquids. So if you pour in liquids of different densities, they will settle into layers based on their density, with the highest density at the bottom and the lowest density at the top. And then something you need to remember is that the density of water is 1 gram per milliliter. So a lot of questions will ask you, here's an object, here's its density, will it float in water? But it won't tell you what the density of water is, because you're expected to know that. So the density of water is always 1 gram per milliliter. All right, so let's do a couple of examples. So here, we have a rock. Again, a squiggly line is a rock. And its mass is 40 grams. But we don't know what its volume is. So here, my water is 10 milliliters. I measured the volume. Then I drop my rock in, and now it has a volume of 20 milliliters. So I subtract the first volume from the second volume to find my total volume, which is 10. 20 minus 10 is 10. And then again, this is a solid. It has CM3 as its label. So what is the density for this rock? So we're going to do mass over volume. We're going to set up our division house. The cowboy always goes inside. The horse stays outside. So this one always goes in. 10 into 40 is 4. You circle your labels. Read them top to bottom. G/CM3. Now, will this rock float or sink in water? It has a density of 4 grams per cubic centimeter. It will sink. Because water has a density of 1, and 4 is higher than 1, so the rock is more dense, and it will sink. Let's go ahead and do our liquid now. So we have green mystery liquid. We don't know what it is. We found the mass of our empty graduated cylinder, which is 10 grams. And then we poured our liquid in and got the mass afterwards, which is 20 grams. So again, we're going to subtract them out. I did not mean to do the same numbers on both. Whoops. So our ending mass minus our starting mass. So our mass of this is 10 grams. And then we measured on a graduated cylinder to find the volume. Look at the lines. So our volume is 40, that should say milliliters, 40 milliliters. So our mass is 10 grams, and our volume is 40 milliliters. So that's how you set up your formula. Always make sure you set that up. And then the cowboy goes inside. The horse, the 40, stays outside. 40 can't go into 10. So you add a decimal in both spots and a 0. 40 goes into 100 twice. 2 times 40 is 80. Bring that down and add a 0. Then 40 goes into 200 5 times. The answer is 0.25. Circle, read them top to bottom. Your label is G/ml. So the density of this liquid is 0.25 G/ml. Now will this float or sink in water? It will float. Because the density of water is 1. This has a density of 0.25, which is lower. And remember, if it's lower, then it floats. So this liquid will float on top of the water. Okay, so one last thing we need to cover about density. Sometimes you need to calculate the mass or the volume because you already know the density. So you may be given the mass and the density, and you have to calculate the volume. Or you may be given the volume and the density, and you have to calculate the mass. You will always be given 2 of the numbers that you need. You need to use this triangle to figure out what to do. So you'll be given 2 of them, and you need to figure out the third one. So make sure that you see this correctly. There's mass on top, division, division, density, multiplication, and volume. So you cover up the info that you're missing, and the triangle tells you what to do. So say you're missing density. Cover that up, and it tells you mass divided by volume. mass divided by volume. So say you're missing mass. We'll cover that up. It says density multiplied by volume. You're missing volume, mass divided by density. So you just cover up whichever one you're missing and tells you what to do. For labels, you cross out the double label, and the one that's left over is what you use. And I'll show you how to do that. Okay, so let's do 2 examples. So for this one, the density is 2 grams per cubic centimeter, and our volume is 4 cubic centimeters. And we need to calculate the mass. So we're going to cover up mass, because that's what we're missing. Cover up mass, density times volume. So I'm going to take my density, which is 2 grams per cubic centimeter, times my volume, which is 4 cubic centimeters, and multiply, that's 8. And then here you cross out the label that's doubled. So we have 2 cubic centimeters. We cross that out, and the label that's left over is the one you use. So that's going to be grams. Also, make sure your label makes sense for the information you're missing. We know that grams is a way to measure mass, so that makes sense. So again, you cover up whichever one you're missing, you do what it says, cross out the double label, and use the leftover one. So let's do this one. Here we're given density and mass, and we're missing volume. So you cover up your volume, and it tells you to divide mass divided by density. So we're going to set up that formula. Mass divided by density. We'll get that mass divided by density. So then make sure you use your cowboy and your horse. The 8 goes inside. The horse, the 1 stays outside. 1 goes into 8 times. And then for your label, you cross out the one that's doubled, so you have grams in 2 different places. And the one that's left over is your label. And again, we check volume, and we know that milliliters is a unit of volume. So we're good.